Welcome to the Bits and PC Online Training Center. In this PowerPoint, we're going to be looking at power supplies and power supply testing. What is a power supply? Well, basically the job of a power supply in a computer is to convert AC energy, or alternating current, to direct current, or DC energy. In your home, the wall outlets in your home, that is AC energy. Electronics cannot work directly with AC energy because it alternates back and forth. It needs a steady power source, and that's why we use DC energy. DC energy is a battery, essentially. Another way we can talk about a power supply is a PSU, and that stands for power supply unit. This power supply unit is going to put out 4 common voltages, and they are 3.3, positive 5, 12 volt, and negative 12 volts. Here's what a power supply would look like. If you open up your computer, you'll see, I call it Medusa in here. It's got all these cables running out of it. And then what we're going to look at is each one of these connectors so you kind of have an idea what they're used for. Another neat technology that's out there today is something called the modular power supply. If you're into building computers, this is a clean way you can build a computer so you don't have this jumble of wires hanging out. When they build these power supplies, they try to build them for expandability. So if you're just building a simple computer, most of these connectors you won't need, and they'll just be in the way and look kind of ugly in the case. The modular power supply, on the other hand, they give you these little headers on the back here, and you just plug in the cables that you need. So if you only need to plug in one hard drive, you just plug in one hard drive. They give you a cable for that. So that's the cool thing about modular power supplies, is you can kind of you build your if you're building a machine, this gives you a very clean look inside the machine. Fundamentally though, there is no difference between these two right here. They both supply voltage. If you was to look at the pricing between this guy and this guy, there is a huge price difference. This guy right here, you're looking $40 to $60. This guy right here, you're looking $80 plus dollars. You can spend hundreds of dollars on just these power supplies, but the main thing about these guys is they're more of a look, not so much of as a feature package. All right, so here are the common power supply connectors you'll see today. The first one we call a 20 pin or a 24 pin. That's what they denote, +4. The new standard now is a 24 pin, and we're going to look at that here in a minute. This is the main motherboard power connector. It will look something like this. It'll have a detachable section if it's a 24 pin. If it's a 20 pin, it'll only have this section and will not have this little doodad hanging off the side there. The next one you may see, depending on the age of your computer, this is being phased out as a 4-pin. We used to call this the CPU auxiliary power. Its job basically is to give the processor a little extra voltage. These are 12 volts, so it gives it 2 extra 12-volt signals. The next one is an 8-pin 12-volt auxiliary. This is what's being, this one here is what's replacing this guy now. It provides more power because our processors have got dual core and quad core and multi cores. They need more power. This guy here can't supply the power that we need now for these bigger processors, and hence it's being phased out with something that can. These are 8 pins, so that basically it's 2 of these put together. It is possible, I don't recommend it. It's a 50-50 shot it would work. The port that this guy uses, you could plug it into that port. Depending on the motherboard and how it's made though, it may or may not work. The danger in doing that, you're not going to blow the computer up, but if you have some high-end processors like an i7 that's overclocked and some other things, you could melt this connector because it won't be able to supply the current load will get too high for it, and it'll start melting that connector. So I don't recommend doing that. If you have a need for one of these particular connectors, you're going to more than likely have to replace the power supply. This one is hit and miss now. It's kind of in and out. This is the Molex connector. Very common on CD-ROMs, hard drives from the 80s all the way up to mid-2000s. It was used very heavily. It has since been phased out by this guy right here called it's a SATA power connector. It's 15 pin It's got a lot more power to it for hard drives and CD-ROMs and whatnot, but it's a lot smaller connector as well. This guy here has been pretty much phased out, except in instances of of the card readers. If you have an internal card reader inside your computer, there was a time period that they used this floppy drive connector power cable to power that. Most of the newer ones now are powered by USB power. So this connector may or may not be on your power supply anymore. It is since being phased out. Another name for this was called a Berg, B-E-R-G connector. All right, the next one is a 6+2 pin connector. It's also 12 volt. We typically see this guy right here. Well, how does that differ from this guy over here? The main difference in this guy, the 6 pins, is very common with video cards today. The video cards, when they're put inside their slots, the slot that's on the motherboard doesn't supply enough power, especially if you're doing a gaming rig. Doesn't supply enough power, so you have to get auxiliary power from somewhere else, and that's what the job of this guy will do. It's 6 pins natively, but has these 2 extra pins hanging off the side here because some video cards will need these extra 2 pins. Most of them that I have seen, unless you're getting a high-end $1,000 graphics card, will just use the 6 pin connector. So here's a 20 pin versus a 24 pin. So this right here, you can see how this is a different color. This is the 20. These are the extra 4 pins. All this white pin assignments back here. This is the original 20 pin connector. Can you use a 20 pin power supply on a 24 pin motherboard? Now, the answer to this is maybe. Why do I say maybe? If you are building a gaming rig and you just found an old power supply to build a gaming rig, I do not recommend that. These extra four power leads are actually for important stuff related to that. One is 12 volt, one is 3 volt, and one is a 5 volt rail, and the last one being a ground. It gives the motherboard a little more power to run video cards and high-end processors that the 20 pin can't deliver. If you was to build a machine that used the 20 pin connector and you put it under some serious load, you put a good graphics card and whatnot in it, even if you did use the 6 pin auxiliary connector, it is still possible for these guys to melt because you're going to be pulling so much current through the motherboard trying to keep the RAM alive and processor going that you could melt these. I have never seen that happen in practice. But if you're just building a machine that's going to surf the web, check email, things like this, an OEM machine like an HP or something like that, you're fine to do this. But if you're going to do something serious with your machine, gaming, Bitcoin mining, or whatever, you're going to want to definitely be sure that you're using a true 24 pin connector for that so that you don't run into issues. Now, power supplies have different form factors, and computers have different form factors themselves. Manufacturers design these cases for different customers that like it different ways. The first one here is the full tower design. The power supplies that I have shown you so far will work with a full tower design. You can usually take them out, go to Best Buy, grab you one for $30, $40, throw one in there, and it'll work fine. However, when you get down into these guys right here, that no longer becomes the case. These become very odd looking power supplies. They get smaller, more compact because the computer is more compact. So you can't just run down to Best Buy and get one. Now you got to order one. And I'm sharing this with you because if you have these smaller machines like this that you're trying to maybe convert to a gaming rig, it's really not practical to do that. You're better off to build one on your own. I've seen so many people try to take the guts out of these and then put them in another computer case or whatnot, and it's just the boards were not designed to do that. They were more designed along the lines of office work. You really need, if you're building a gaming rig like that, to get one that is actually designed to do gaming. So here are some different power supply form factors. This is not all inclusive. Okay, this is just a a small sampling of what you get. So they can be elongated. They can be more of a box type. This is a very old power supply right here. This is the ones that was used in the old, if you know anything about computers from the old days, at the 286, 386, 486 power supplies. That's what this guy was used for. This is an IBM power supply, and you can see it's got this weird little step in it. That is not uncommon when you start getting into those weird little form factors. Now that we've looked at the different types of power supplies, we now need to examine how we can test them. There are different ways you can do this. If you have a digital multimeter, one of these guys right here, or one of these guys like this, you can test voltages outright. There's also a tool that I recommend more than the digital multimeter here, because it's just easier to use and you get a full picture of what's going on with the machine, and that is to use a true power supply tester. And this is a really nice one. This is by Thermaltake. It will actually test all the voltage rails in the power supply for you at the same time, and it'll let you know if there's one of them that's messed up. This is the easiest way to do it. These are around $30, $40 for one of these testers. Sometimes you can catch one of these digital multimeters on sale at Harbor Freight for free. They're okay. They kind of get the job done. I wouldn't use them to test, AC energy with, because I found that the leads on them are not, the leads or these things here are not very good. You could get electrocuted, but if you need it to do some simple voltage testing in the machine, it is possible. But I wanted to share with you this. There are two types of digital multimeters, and if you go looking at prices at them, you're going to see that prices go from $10 to a couple $100, and that mainly comes from the feature set that they do. Like this Fluke meter. Fluke is like the Cadillac of testing equipment. So if it's got the name Fluke on it, it's at least $100. This is an auto ranging meter, and what we mean by auto ranging, you just turn the thing to voltage and it will read. A non-auto ranging meter would look like this. It's where it has all these different scales on it. So if you look here, this is V with a straight line. That is volts DC. And if you come down here, you'll see this guy's got a wavy line there. That is volts AC. Now, when you're testing computers, like I said, the power supply is DC, so you would be using this scale right here. And what you do is you turn the knob to your expected voltage. So if you're testing the 3-volt rail, if you turn it to this number, that's 2 volt, that means the maximum it will read is 2 volt. So if you're going to read the 3-volt rail, you actually have to turn it to the 20-volt mark. So these are the top numbers. So when you turn the knob to 20, that's the highest voltage it will read. So if you try to test something that's 25 volt on the 20 volt scale, it'll just show an overload. So you have to go up to the next voltage level. If you turn it up too high, like if you turn this up to 1000 volt and are trying to test a 3-volt rail, the number will give you a very, very small number that won't be meaningful to you because it'll have so many zeros in it, and it doesn't give you it'll just say 3 on the end of the scale. It won't give you if it's 3.31 or whatever, because that last number, because 3.31 is the mean, that's where it should be, but there is a scale that you have to look at to see if it's within range. And if you have it turned up too high, you won't be able to see if it's 3.31 or 3.10 or whatever. So that's why you have to have it on the correct scale. The auto ranging meter automatically will take care of that for you. It'll automatically pick the voltage that it deems to be appropriate. All right, the DMM, how would you use a digital multimeter? A digital multimeter, basically, you just put it in. You put it on one side of the circuit and put it on the other. So in this battery module here, this AA batteries are 1.5 volts or 1.5 volt. And you put the leads on one end of the battery and you put the lead on the other end of the battery, and you're going to get a reading. Now, I picked this picture for a particular reason. If you look at this, it says a negative 1.629 volt. Okay, if you ever get a negative number when you're doing power testing, that doesn't mean that the battery is actually putting out a negative 1.6 volts. It actually means you've got the leads reversed. If you look on this battery right here, if you can see it, it says positive right here. The red lead, this guy right here, is always positive. The black lead is always ground, or it's always negative. So they've reversed the leads on this, so you will get a negative number. So if you're testing in DC circuits and you get a negative number, that means you've got your leads reversed. There is one exception to this. We're going to look at it here in a minute when we look at pin assignments on power connectors. There's only one voltage on the motherboard today that's a negative voltage number. These are some common symbols you could see on the digital multimeter. The wavy line would mean AC voltage. The straight line is DC voltage. You would have to know the difference between the two, because if you try to test a battery on AC voltage, you won't get a reading. So you have to be on the right. You have to be on the right scale. So in power supply testing, you're going to look for that symbol right there, and you have to go to a ground source. So you have to go positive and negative, okay, on your source. Another caveat to power supply testing, if you're going to test with a digital multimeter, when you plug the power supply in, it will not come on. There's a power switch that's on the back of it. You can flip that to on, and then you can put your probe, in here, and then put another probe down here, and the orange should be 3.3 volt. The black is the ground, so you always go from a source of power to grounds. So your black lead, basically in computers, the black lead will always be on a black wire, and the red lead will just move around to the different colors if you're doing power supply testing. However, when you're doing this with a multimeter, if you're not going to use the thermal take meter, you've got to turn the power supply on. The switch on the back does not turn the power supply on. That just that turns the circuitry on inside the power supply. The power supply is not actually outputting anything. So you manually have to do a jumper to turn the power supply on. Now, it's going to go against every cell in your body to do this, but you're going to take a paper clip and you're going to jam it into the 20 or 24 pin connector. This will cause the power supply to turn on. Now, when you're doing this, it's kind of important that you actually jumper the right wires, because if you jumper the wrong wires, you'll blow the power supply up. So what you're going to look for, and this is a standard now that's been in for 20 years, so you don't have to worry about, a new power supply or an old power supply. They pretty much work the same. You're going to look for this wire right here, this green wire. This green wire is a special wire. This is the power on signal wire. What you've got to do, you've got to jumper that guy to ground. It's a 5-volt signal, so it's not going to shock you or anything like that. You can hold on to the paper clip while you're doing it. You don't need needle nose pliers or anything. You're not going to feel anything. And you're going to jumper that to ground. Now, if you look around this guy, it's really hard to mess it up, because if you look to the right of it, it's got a black wire, and if you look to the left of it, it's got a black wire. So it's surrounded by grounds. So you can go to any black wire on this connector if you want to. I always jumper between either the one to the right or the one to the left of it, but that is your preference if you're having issues with it. Just don't jump it to any other color. So green to black, you're going to be fine. Don't jumper it from green to orange or green to yellow or any of those other colors, because you can mess up the power supply or burn it up. Now, the other thing, if you're going to use a digital multimeter, you're going to get readings with it. You need to know if your readings are conducive of a good power supply. These are the tolerance bands that the ATX people tell us are okay. So if you're testing the 3-volt rail, they're saying that it has a tolerance band of plus or minus 5%. So these are the numbers. The nominal, that means normal voltage. That's the center line. So if you're on, if you got a reading and you got a reading of 3.14 to 3.47, in that range, the power supply is doing fine. However, if you got a number that was lower than 3.14, if it was 2.8, that would tell you that the power supply is actually faulty. Okay. There is no way to fix this. If you have one of these rails right here, these are the output rails, 3-volt, 5-volt, 12-volt. If you have one of these rails that are out of tolerance, so if the 12-volt rail is reading below 11-volt or 11.4 volt, you're going to have to replace the power supply. There's no way to fix just one of these rails within a power supply. If one rail is bad, they're all considered bad. The transformer inside the power supply is actually failing, and that's why you see this. But anyway, there is a little bit of a tolerance band change when it gets to the negative 12 volt range. So keep that one in mind. But this little table is a handy little table to keep if you're going to do power supply testing by hand. The Thermaltake tester will tell you right then and there if it's a good power reading or not. And then that green wire that I showed you earlier, that is the 5-volt signal. That is volt standby. So it should have a reading. If you put your meter, if you actually put your multimeter on that paper clip, you'll actually see a voltage reading. You should see it between 4.75 and 5.25. Generally, I see the higher numbers on newer power supplies or higher end power supplies, because as power supplies age, they naturally age downward, into the lower voltages. All right, here's a good little slide if you want to print this. I'll provide this for you in your Moodle handout, so if you want to keep this for testing or whatnot. But these are what the connector should have. So if you was to pull that we're going to use a 24 pin connector because that's more common. If you was to pull that connector apart, this little piece right here that you see, that's that clip, so this gives you a reference. These voltages down here, this is the end of the this is the end of the right side of the connector, so this would be the left side of the connector. And all and they're color coded. So if you see yellow wires in here, those are all 12-volt wires. If you see a red wire, those are all 5-volt. If you see a blue wire, which there's only one here, that's the negative 12. Basically what that is, this is voltage that's flowing in reverse. So voltage actually flows from the negative side to the positive side. Most people think it goes from the positive side to the negative side because when you hook your car battery up, that's the side that always sparks. It actually goes the opposite way. So when you're in a negative setting, your voltage is actually going from the positive side to the negative side. We see that a lot with telecom equipment. We use negative 48, negative 24 are very common voltages, and that's for actually safety of the technicians that are working on it in case there was a lightning strike or whatnot. But in computers, I looked it up. I could not really find anything that uses the negative 12 volt rail, but it's on there for some particular reason. Black will always be ground, and your orange will always be your 3.3. And you can see that as you look at the different connectors. So when you're looking at power supply connectors, you'll actually now know the color code, which you should see when you're doing your testing. So if you had your probes and you wanted to test this 4-pin auxiliary, what you'd do is you'd put your red probe there and you put your black probe there, and you should get the 12 volt across it. If you put the red there and the black there, because they're both 12 volt, you'll get a reading of 0. Or if sometimes if there's a little difference in the voltage, you might see that, but you shouldn't on a short power run that the power supply is putting out. But anyway, these are just the connectors, how they're pinned out as far as if you're doing manual testing, what you should expect on each connector. Another quick way you can determine a power supply, if it's failed or not, is just look at the motherboard. Most motherboards today have some form of LED light that's on there. The green, blue, orange, yellow. They're usually, and if you have just a standard computer like a HP or Dell or something, they're usually green. But that just basically means that the power supply is giving power to the motherboard through its 5-volt signal, so it is getting power. You don't ever want to work on a computer if that light is on, because that motherboard's hot, and if you ground something out you're not supposed to, you can fry the board. If you have the power supply all plugged in and it's plugged in the wall and everything looks fine, and you don't have this green light, that's when I would suggest you pull out your multimeter and let's start digging to see if that power supply is faulty. Just remember, before you start doing that, to jumper the power supply on first before you start testing, because if you test without that paperclip jumper in there, you're not going to get any voltage, and I don't want you to throw away a power supply that works perfectly fine. The power supply tester that I showed you, that will allow you to turn it on through the tester itself. All right, power supply troubleshooting and symptoms of a failed power supply unit. The most obvious is the computer won't turn on. Another one we just spoke about, the LED on the motherboard, the green LED, will not be on. In some instances, you may smell it. Power supplies that smoke themselves, you may smell I call it a gunpowder smell. If it's a hot plasticky smell, that means it's one of those connectors inside that's burning up. But usually it's a strong gunpowder smell that you'll smell when you lose a component in a power supply or on the motherboard. If you have a power supply that the fan isn't working on anymore or is getting extremely hot, that is another symptom of a failed power supply, and you need to replace it. There's no way you can just fix the fan. Let me stress this to people. People are like, "Oh, let me see what I can do with it." If the power supply is dead, it's dead for a reason, okay? These things don't just, you know, they don't just die for no reason. They die from old age. They die from lightning strikes or whatever. They don't just die for any particular reason. Lastly, frequent lockups or blue screens of death. Power supply troubleshooting with computer issues is extremely difficult because the power supply does not have any circuitry in there to tell you if it's going bad or not. That's why we have to go through all these testing procedures to determine if it's bad or not. However, if a power supply is failing intermittently, so one of those rails, the 12 volt, the 3 volt, the 5 volt rail or whatever, let's say one of those things starts blipping. They start turning on and off, like the 3 volt rail. That's usually common with the 3 volt rail. You'll lose the 3 volt rail and it'll come back real quick. Well, the 3 volt rail controls the processor. So if the 3 volt rail goes down, the processor will shut down and then it'll come right back up and it'll lock the processor up. You'll perceive that as a lockup on the machine or a blue screen of death if it gets that far. It can also cause the RAM to freak out because if the voltage goes on and off on the RAM, data stored in RAM gets corrupt if power is lost to it. So it is possible for a power supply to contribute to a computer malfunction. It's extremely hard to diagnose because you're not going to be able to, more than likely, if it's a blip like that, it's going to be so fast you're not going to be able to see it with a digital meter. The only way I have found that you can test if you believe it to be a faulty power supply is to replace the power supply with a known good power supply and run it and see if that fixes it. If that does not fix it, I would suspect the board has got some sort of issue with it. So power supplies, 90% of the time that I have dealt with them, they fail gracefully. And what I mean by fail gracefully is the computer just won't turn on. You'll turn the computer off one day, you'll go to turn it on, and it will not turn back on because the circuitry that boots the power supply is dead. As long as the computer was running, it was doing its thing, but as soon as you shut the machine off, the power supply dies right then and there. These are very common instances. If machines stay running for very, very long periods of time without being shut down, this can happen. So hopefully if you're dealing with a power supply issue, it fails gracefully and you know it's just a bad power supply, you go on and replace it and you have a good day. But if it's a infrequent issue with locking up and things, because lockups can be caused by besides bad voltage regulation to faulty RAM, faulty processors, faulty code in an operating system. But I want to share this little tidbit with you. As computers age, so when power supplies start getting around 4, 5, 6 years old, this is when these problems could start to become more prominent with the not working anymore. Another thing that happens is this. These are called electrolytic capacitors. These are located all over the motherboard. There's also some inside the power supply. They're basically the same stuff as a AA battery. What they do is they're basically small batteries that charge up and discharge extremely fast. And they do wear out eventually. The electrolyte material inside dries up and then they quit working. You can look at a motherboard and determine a lot of times if they're having weird issues or the machine won't boot anymore or won't come on. Look at the motherboard first and look at these things. If they're split like this, they're bad. It's over. Can you take these off the board with a soldering iron and replace them? They're only like 10 or 15 cents. Yes, you can. However, in practice, it's extremely hard. The way that motherboards are built, they're wave soldered, so they go over a vat of molten lead or lead. Well, it's not lead anymore, but tin solder. And this stuff, when they put it on there with a regular soldering iron, it is almost impossible to get these things off the board. Most times when I see this happening, I end up replacing the board itself with a new board just to solve the problem. But this is a quick diagnostic you can do on a machine if it won't boot. If you're suspicious of the power supply, first thing I'd do, get you a flashlight, shine it around, look at all these guys on the motherboard. This one right here at the bottom, this is a healthy capacitor. You can see that it's smooth. It doesn't exhibit a split, but these have a bubbled dome to them, and they are split in the center. So that is indicative of a bad capacitor, and the component's going to have to be replaced. Dangers of power supplies. I can't stress this enough. These things are not that expensive in most instances. They're not serviceable. You don't open them up and tinker around with them. These things have extremely large capacitors in here that can blow you across the room, could cause cardiac arrest, severe burns, lots of bad things, and they're not worth it. They're just not worth trying to fix. If the fuse in here, there is a fuse in here that's usually soldered to the board. If that fuse blows, it blew for a reason. Either the transformer shorted out, or a capacitor shorted out, or a voltage MOSFET or regulator burned up. There's a reason why that fuse blew. We don't open them. You can open them and look if you want to, but don't touch anything in there. When they are defective, we throw them away. They're what we call a non-serviceable part. Another non-serviceable part that can seriously ruin your day or ruin your life is the big CRT monitors, the big TV tubes. Those have extremely high voltage capacitors and transformers in them that do not discharge necessarily when they're unplugged. And that's the danger of these things. You can have this thing unplugged sitting on your workbench for 2 days and then go to open it up, and these things still have enough power in them to weld your screwdriver to a case. So they are still dangerous even though they're unplugged. That's when people get hurt thinking, oh, I've unplugged it, I'm safe. Not necessarily. I had a TV that was unplugged for 3 weeks, and when we went in to discharge the power supply in it to work on it, it still had enough charge in it to throw a 4-inch spark. So these things don't necessarily bleed down like some circuits do. Redundant power. Now, redundant power, basically backup power. We typically find these on servers or other expensive equipment that has to run 24/7 or has high uptime or critical applications or whatnot. So this is a backside of a higher end server, and it's got 3 power supplies in it. And the reason why they do that is if one of these guys fails, the other power supplies can take on the load and the machine will keep going, so you can order you another power supply. And these are hot swappable too, so what they mean by that is you don't have to turn the machine off. You just release the lever, push a button in or a lever and remove the old one, put your new one in, lock it down, plug it in, and you're good to go. Another one maybe on your home computer you might have is a UPS. There is a battery that's inside of that regulates, that will make AC energy for your computer so that the power supply can then convert it back to DC. This is very common with computers that can't go down during a power failure. Your desktop may have one, in case power goes out, it gives you enough time to shut everything down safely. Cash registers, things like that, will use these to keep up in the event of a power blip so that they can, finish your order. But these are different ways you can keep equipment running. This is a Smart Ups. These are high-end backups. They also make a backups line, which is a lot cheaper. Like this one here is like $1,000, but the backups line, which is more of a home grade thing, uh, the power is what we call dirtier. Uh, it, it's uh, it's not as clean. So if you know what a sine wave is from math class, so just a wavy line, uh, what you're paying for is how clean that wavy line is. If it's real jagged, you know, that's what this guy right here will clean up. So if you're saying, well, what's the difference between this guy and this guy? It's just basically the circuitry they're using to make that sine wave as clean and crisp and flow nicely, basically. Lastly, I want to look at power supply efficiency. Power supplies, guys, are not 100% efficient, okay? They're around best, if you want to pay for a good one, 87%. The rest of that is lost as heat. That's why they have a fan inside of them. So if you buy a 500 watt power supply, cheaper, the lower end one here, the 80 plus, it's actually only going to put out 400 watt of continuous power. It will not give you 500 watt. Okay, if you was to spend more money and get the gold series, it would give you 435 watts. Uh, it's been my experience, if you're doing a computer design, that you have a power supply that's at least 500 watts. I would recommend something higher now, 800 watts or 1,000 watts. What you have to remember is when you're doing if you're doing a gaming PC or whatnot, you can get how much power each thing uses. So when you buy your processor, it'll tell you how many watts the processor uses. If you're using a high-end graphics card, it'll tell you how much. You just basically just add all that up together and make sure that you get a power supply that will meet your needs. Now, if you added it all up and you came out to 415 watts, you're like, okay, I can buy a 500 watt power supply, 80 plus, not the gold, but just the 80 plus. And the answer to that is no, it won't work. You'll actually be overloading the power supply because it's not designed. It's 500 watts peak, and then 400. What they mean by peak, that's just 500 watts briefly, not a sustained voltage. So power supplies are misleading in that particular case, because if you buy 1,000 watts, that doesn't mean you're going to get 1,000 watts. At best, if you was to do this calculation, you're going to get 870 watts out of that. So just keep that in mind. These are the different tiers for power supply. They go from 80 plus to 80 plus gold, and you can see that these are the power efficiency. So if it's at 50% load, so it's running at half capacity, so half of your 400 watts, so around 200 watt, you get 90% efficiency. But if you're at 100%, it's going to get back down to 87% efficiency because of the heat load. Power factor, basically, that just is a measurement of load to current that's available. So the closer it gets to 100%, that means you're using everything that the power supply is putting out, which is actually a good thing because that increases the efficiency. As you move closer to 1 or 0 value, that means your power supply is making all this power, but nothing's really using it, which isn't very efficient. So that's what a power factor load would be. In case you were curious, you don't really have to worry about that. When you do design or replacement, you just need to make sure that you get the same wattage. If you're just replacing one like a Dell or Compaq or whatever, it'll tell you on the sticker. If it's 350 watts, you can put a 500 watt power supply in there. That's not going to hurt anything. You're just going to have extra capacity. But you couldn't go get a 200 watt and put in a 350 watt computer because it's not going to work right. So just be sure whatever you get will meet or exceed that number that was on the original power supply, and you'll be fine. Here's a neat little website that goes through every little power connector if you're curious to see exactly the history of it and whatnot. If you're interested in that kind of thing, this is a neat little site to look at that. But that will conclude this section on power supplies. I hope you enjoyed it. I hope you learned something from it. If comment on it, send me an email or whatever if you see suggestions or comments or anything that liked about it or want to know more about, we can see what we can do. Y'all have a great day. Thank you.